This is the first in a series of MATLAB computer sessions where we will eventually develop a fully functional and rather feature-rich one-dimensional finite difference time domain code. We will do this in a series of steps, starting simple and then slowly adding our bells and whistles. And even when you understand this fully, I would definitely recommend developing codes following a sequence similar to this. It's a mistake to just jump in and try to code up a fully functional code, and when you get everything written, hit run for the very first time, then of course that won't work, and we have to figure out what goes wrong or where things are wrong, and that's very difficult. But it becomes much easier if you build your code in stages. So that's exactly how we're going to do it here. In this first code, we will simply build the basic finite difference time domain engine where we update E from H and update H from E, and set that up to go back and forth, back and forth, back and forth. The assumption here is that you've listened to the theory lectures on the course website, and only after you've been through that are you looking at this code. So we will connect the code to the theory, but I'm not going to take any time here to explain the theory. That's in the theory lectures. So with that said, let's get started. We're writing a finite difference time domain 1D, and this is the first step, simply where we're doing the basic finite difference time domain engine. The first thing I like to do is initialize MATLAB. We will close all open figure windows. We will clear the command window. And the most important is to clear all variables from memory. The next thing I like to do is define my units. I like to be in the MKS system, and this is particularly useful for finite difference time domain. So we'll set meters to 1. So if we have a variable A, we say A equals 3.7 times meters, then A is 3.7, and that means meters. And we can define other units from that. For example, centimeters is 10 to the minus 2 times meters. Millimeters is 10 to the minus 3 meters, and so on. We could define micrometers, nanometers, and so on. We'll stop here, but we'll define inches, and that's 2.54 centimeters. Feet, 12 inches. Then we can go on to seconds. If we wanted to, we could do milliseconds, microseconds. I'm not going to do that. I'll just use seconds. But we'll go on to hertz as 1 over seconds. And we have kilohertz as 10 to the third hertz, or 1,000 hertz. Megahertz is 10 to the 6th times hertz. Oops. And gigahertz is 1 times 10 to the 9 hertz. And we won't do anything else. So what we'll do is we'll compact all this together. And because I'm weird, I like to align the equal signs. I think it just looks nicer. Okay, now once we have the units, we can define some constants. The speed of light, that is 299,792,458 meters per second. Notice I'm using all the digits. I'm not just saying 3 times 10 to the 8 meters per second. The free space permittivity, 8.854,1878,176 times 10 to the minus 12. It's farads per meter. We haven't defined farad units, so we'll just say 1 over meters. Free space permeability, 1.2566370614 times 10 to the minus 6 times 1 over meters. Hopefully I didn't do any typos here. The code will still work. If we make a small typo here, we just may suffer in the accuracy a little bit. And then the last thing is to open a figure window. So we'll use the MATLAB command figure to do that. We'll give it some parameters, and we'll say color and W for white. This opens up a figure window with a white background. Let's go ahead and run this code and check for any errors we might have done. Oh, forgot to save it. FDTD 1D step1.m. Okay, then it runs it, and up pops a figure window with a white background. And no errors, so it looks like we have not made any typos. Now we're going to create what I call the dashboard. This is all the hard-coded numbers in your program. So if you have a dimension of 1 foot or 2 centimeters or a frequency of 1 gigahertz or any of this kind of stuff, all of these numbers appear in the dashboard. No work is to be done inside the dashboard. Once we're done with the dashboard, no more hard-coded numbers. Everything is relative to what happens inside.